halfway between our Sunday and the nearest of all other stars, there is a place you could stand and still not see where you are going. It is a strange piece of arithmetic. 2.12 light years from home. At the midpoint of that crossing, our own Sunday is still the brightest star in that sky, the easiest thing in it to find, while Proxima Centauri, the star you set out to reach, is still not there at all for the unaided eye. Half the journey behind you and the destination still unseen. Tonight we walk that gap slowly. We will shrink the whole crossing down to something you could lay out on a table, stand at the exact middle and look both ways, and find out why the gap between them is not the perfect emptiness we picture. Anyone you know who lies awake past midnight is welcome here too. Pass this along and let it sit with them through the long part of the night. Nothing tonight asks to be figured out. Let the pillow take the weight of your head and let the room go soft at the edges. If sleep arrives before we reach the middle, that is exactly what this is for. Let's drift out. Somewhere above the roof you are lying under right now, that same sky is turning, slowly, the way it turns every night, whether or not anyone is awake to watch it. You do not need a telescope for what comes next, only the plain dark overhead and a little patience. Most of what fills that sky is already familiar in outline, if not in name. A handful of bright points that do not flicker the way ordinary stars do, planets in our own family, closer and steadier. Behind everything else sits a great scattered wash of fainter light, the combined glow of more stars than any eye could ever count one at a time. And somewhere in the mix, one particular patch of sky toward which, tonight, we are going to walk. We are not going to travel there quickly, and we are not going to travel there the way a spacecraft would in a straight, urgent line. Instead, we are going to walk it the way a very long, very calm hike gets walked. One landmark at a time, resting often, looking back at where we started as often as we look ahead. There is no clock running on any of this. A real walk this long would take longer than any single lifetime to finish on foot. And that is fine, because finishing is not actually the point of tonight. The point is simply to move, slowly, from one quiet landmark to the next, the way attention drifts on the edge of sleep, following one thought a little way before, letting it go and settling on the next. Whatever pace your own body is keeping right now, under whatever roof you happen to be lying beneath, is the correct pace for the rest of tonight. There is nowhere this walk needs you to be in a hurry to reach. If your eyes are already heavy, let them close on their own schedule, not on this one. The stars this walk is about to describe have been sitting exactly where they are for longer than any single night could rush. Along the way there will be a handful of numbers worth holding, a boundary or two worth crossing, and one particular spot, right at the middle, worth stopping at for a while. None of it needs to be remembered by morning. It only needs to be walked through once, tonight, at whatever pace lets your own body settle. The first landmark is not far. It is close enough that you have probably looked straight at it without ever knowing what you were looking at, and it will turn out to be the quietest kind of surprise this whole walk has to offer. Something near, hiding in plain sight, simply by being too dim to notice. That is a gentle enough place to begin any long walk, with something already nearby rather than something impossibly far off. The far distances will come later, and they will come slowly, one small step of scale at a time, never all at once. No part of tonight asks you to hold every fact at once. Each landmark gets set down fully before the next one arrives, and nothing from earlier in the walk needs carrying forward by memory alone. Whatever settles is welcome to stay. What slips quietly away by morning was only ever meant to be walked through once, gently, tonight. Start with the one thing in that sky you have never once seen. Somewhere in the stretch of sky you were just looking at, the nearest star to our own Sunday is sitting right now, and you have never seen it. Not with a telescope missed at the wrong angle, and not with cloud in the way. It has simply never been bright enough for a human eye, unaided, to catch. Proxima Centauri is the nearest known star to the Sunday, closer than any other star we have found. By any ordinary logic, nearness should mean visibility. The nearest lamp in a dark field should be the easiest one to find. Here, that logic simply fails. Astronomers measure how bright a star looks from Earth with a number called apparent magnitude. And the rule with that number is the opposite of what you would expect from an ordinary ruler. Smaller numbers mean brighter, and every larger number is dimmer by a wide compounding margin. Proxima's apparent magnitude sits at about 11.1. The faintest a healthy, unaided human eye can generally manage, on a clear night, far from any city light, is around magnitude 6. 11.1 against 6 is not a small gap. Each full step in that scale is itself a large jump in brightness, and 11.1 sits many such steps past 6. Proxima is not simply dim. It is planted firmly on the far side of a line the unaided eye cannot cross, no matter how dark the night or how patient the observer. The scale itself is worth a moment, since it is older than it looks and stranger than it sounds. It was first sketched by an ancient observer, sorting the sky's brightest stars into 6 rough tiers by eye alone, then refined centuries later into the precise compounding ladder astronomers still use tonight. Each step down that ladder means a star is meaningfully harder to see than the one above it, not by a fixed amount, but by a widening ratio. So a star 5 or 6 steps below the naked eye limit is not simply somewhat fainter. It is fainter by a factor large enough that no amount of squinting, no amount of waiting for the eyes to adjust will ever close the gap. This is not a limitation of modern instruments or modern eyes. No human being, at any point in the long history of anyone looking up at the night sky, has ever picked out Proxima Centauri without the help of a telescope. Every naked eye star chart ever drawn, going back thousands of years, across every culture that ever named the stars it could see, simply never included it, because there was never anything there for an unaided eye to record. It is worth being precise about what a telescope actually does here. Since it is easy to imagine, it's simply making things look closer. A telescope does not shrink distance. What it does is gather light, collecting far more of it over a wider opening than the small aperture of a human pupil ever could, and concentrating that gathered light into an image bright enough to register. Proxima is not too far to see. It is too faint, and a telescope solves faintness, not distance. That distinction matters for the rest of this walk, because it will come up again. Some things out here are hidden by true distance, so far away that no amount of light gathering will ever be enough. Others, like Proxima, are hidden by simple faintness, sitting closer than almost anything else, yet still invisible for a completely different reason. The two kinds of hidden are easy to confuse and worth telling apart early. There is a modest kind of comfort in a fact like this, quietly reassuring to sit with. The universe is not hiding its nearest neighbor out of any particular design. It is simply a small, quiet star doing what small, quiet stars do, which is glow gently rather than blaze, and asking nothing more dramatic of the observer than patience and the right instrument. A homely comparison helps here. Imagine the house nearest yours on your own street, and imagine that house is the only one out of every house for miles, with no porch light burning. Every other home, some of them farther away, some of them much farther, shows something. That one, the closest of all, shows nothing, simply because nobody switched anything on. Proxima's situation is roughly the same. Its nearness buys it nothing. What decides whether a star gets noticed from Earth is not how close it sits, but how much light it happens to be putting out. And Proxima, as this journey will return to later, is a small and quiet kind of star, dim by nature rather than by distance. Meanwhile, some of the brightest points in the night sky sit far, far beyond Proxima, sometimes hundreds or thousands of times farther away, and still outshine it easily, simply because the stars themselves are putting out enormously more light to begin with. Distance and brightness pull against each other constantly across the whole sky, and nearness alone almost never wins that contest on its own. It is a useful habit to carry for the rest of tonight's walk. This small correction about what nearness actually promises. A star can be the closest thing out there and still ask real effort to find. Distance is only ever half of what decides whether something in the sky gets noticed, and it is very often the smaller half. So the walk begins with a small correction to an assumption most people never think to question. Being the nearest thing out there does not make a star the easiest thing to find. It only makes it the nearest. Visibility is a separate question entirely, and it will keep mattering again and again the farther this journey goes. Astronomers did not always know it was there, either, which is worth remembering before this walk gets too far ahead of itself. Proxima Centauri was only identified as a distinct, separate star and confirmed as the closest one to the Sunday. In the early years of the 20th century, found by careful, patient measurement of exactly the kind that would eventually pin down its distance to 4 decimal places. Before that, its faintness had simply let it sit unnoticed among a great many other equally dim points scattered across the same general part of the sky. Once found, it needed a name, and the one it received says plainly what makes it worth talking about at all. Proxima is simply Latin for nearest. Not brightest, not largest, not most remarkable in any of the usual ways a star earns a name. Only nearest, which turns out, once the arithmetic settles, to be exactly the right thing to be remembered for. Hold that plain fact loosely for the rest of the night, because it is going to matter again soon in a slightly different shape. A thing can be the nearest example of something and still be, in almost every other respect, entirely ordinary. Proxima's whole claim to attention is a single measurement, a distance, rather than anything unusual about the star itself. The star underneath that measurement, as this walk will find later on the far shore of the crossing, turns out to be a fairly modest, quiet little thing. Records like this one, the record for nearest anything, tend to attract more interest than the object actually holding them strictly deserves on its own separate merits. And there is nothing wrong with that. A record is simply a useful excuse to look closely at something that might otherwise never earn a second glance. Proxima earned its evening in this particular spotlight by sitting closest, not by being remarkable in any other way. And that turns out to be plenty of reason to spend a whole walk getting to know it properly. And it is not even alone out there. The bright point people actually do notice in that part of the sky. The one that gets pointed at is not Proxima at all, and it is not even one star. Alpha Centauri is a triple system. Two of its three stars, called simply A and B, orbit closely enough around each other and shine brightly enough together that from Earth they read as a single dazzling point, one of the brightest stars in that entire part of the sky. Star A is a G-type star, close in size and temperature to our own Sunday. B, its partner, is a somewhat smaller, somewhat cooler, K-type star. Together they sit at about 4.37 light-years from the Sunday. Locked that close together, A and B do what any true binary pair does. They orbit a shared center of mass, rather than either one holding still while the other moves around it. Seen edge-on from far enough away, the pair would appear to swing closer together and farther apart across the years, tracing a long unhurried ellipse rather than a neat circle, the two stars trading distance for speed, the way any two bodies bound by gravity always do, closer and quicker at one end of the ellipse, farther and slower at the other. None of that motion is visible to an unaided eye watching from Earth. It shows up only in careful, repeated measurement, the same patient discipline that pins down every other number this walk relies on. Proxima is the third member of that family, and it is the outlier in every sense. It orbits the A and B pair from very far out, roughly 0.21 light-years of separation, something on the order of 13,000 times the distance from the Sunday to the Earth. At that distance, one full lap around the pair takes something like 550,000 years. The last time Proxima completed a single orbit, nothing resembling written history existed anywhere on this planet. It helps to hold that number, 550,000 years, against something more familiar. Every human civilization that has ever kept a written record, every language, every city, every remembered name, fits comfortably inside a sliver of even one of Proxima's laps around its bright companions. The orbit itself is not rushing anywhere. It is simply patient on a scale that makes ordinary human patience look brief by comparison. A pairing that close and that bright, A and B locked together at a separation modest enough that both stars finish a shared orbit in a span closer to a human lifetime than to Proxima's own crawling 500,000 years, behaves almost like a single object from any real distance. It is only up close, astronomically speaking, that the two resolve into a genuine pair rather than one blended point. So the nearest star to the Sunday is not the star anyone actually sees when they look toward that part of the sky. It is the faint, outlying member of a bright pairing that gets all the attention, sitting so far from its own siblings that calling the three of them a single system asks a fair amount of the word system. There is a kind of quiet humor in that arrangement, though nothing about it was designed. The brightest thing in that patch of sky is not the destination. It is a bystander, a much larger and much closer pair that simply happens to sit along the same general line of sight and share, loosely, the same neighborhood. Proxima rides along at the edge of somebody else's spotlight without ever stepping into it itself. None of the three stars are doing anything unusual by existing this way. Multiple star systems, 2 or 3 stars bound together by gravity, are common across the galaxy. What makes this particular arrangement worth pausing on is simply that it happens to be ours, the nearest example of the pattern, and the one this whole walk is aimed at. Astronomers refer to the 2 brighter members simply as Alpha Centauri A and Alpha Centauri B. Letters rather than names, a plain bit of bookkeeping that turns out to matter later, once this walk starts talking about what each star looks like from up close. A, the slightly larger and slightly brighter of the pair, is classified as a G-type star. The same broad category the Sunday itself belongs to. B is a cooler, dimmer K-type star, still bright, still substantial, simply a size and a temperature step down from its partner. Because it resembles the Sunday so closely in size and temperature, it has drawn a great deal of careful study over the years, in part simply because it offers a rare, nearby comparison for a star so similar to our own. B, quieter and cooler, has drawn less attention on its own, though it shares the same orbit and the same long history as its brighter partner. Between the two of them, they carry the overwhelming majority of the mass and the light in this entire triple system. The letters after each star's name, the G and the K, are shorthand from a much longer classification scheme astronomers use to sort stars by surface temperature and color rather than by size or brightness alone. A G-type star, like the Sunday and like Alpha Centauri, runs hot enough to glow a clean white, tinted only faintly warm to a careful eye. B, cooler by a step, is a K-type star. Its light shifted a shade, further along the same scale. Neither classification says anything about how far away a star sits or how bright it happens to look from any particular distance. It is a statement about the star itself, the same kind of statement this whole walk keeps circling back to, what a thing actually is, held apart from how far off it happens to be. Being locked in a mutual orbit this tightly, close enough that both stars raise real measurable tides in each other across the whole shared history of the system, has not disturbed either star's own long, ordinary life. Stars in binary pairs are common enough across the galaxy that astronomers no longer treat close companionship as anything unusual. What kept this particular pairing stable long enough for planets and patient orbits to settle around it is simply distance held in a durable balance, close enough to bind, far enough that neither star crowds the other into anything more dramatic than a slow shared dance. It is worth being precise about what each of these 3 names actually means, since the rest of this journey will keep returning to them. Alpha Centauri spoken alone usually means the bright combined pair, A and B together, the one visible from the ground. Proxima Centauri is the separate, dim, outlying third member, the one that carries the record for nearest star, and the one this walk is actually headed toward. They share a name and a rough neighborhood. For the purposes of tonight, though, they are not the same destination. This confusion is common enough that it is worth naming plainly, rather than assuming it away. Someone hearing for the first time that the nearest star to the Sunday has been found might reasonably picture the bright, easy-to-spot pair that anyone in the southern hemisphere can point to on a clear night. That bright pair is a genuine, real, and remarkable neighbor. It is simply not the record holder this particular walk has set out to reach. Keep that small distinction in mind as this journey continues, because from here forward, every use of the word Proxima refers specifically to the dim, distant, outlying star, and every crossing this walk measures is a crossing toward that one particular point, not toward its brighter, closer, more easily noticed neighbors. Which leaves one number to sit with before we take a step. Proxima Centauri sits 4.2465 light-years from the Sunday. In the other unit astronomers sometimes prefer, that is 1.3020 parsecs. Neither number is rounded for effect. This is simply how finely that distance has been measured, decimal by decimal, by patient work, stretched across more than a century of careful observation. A number carried out to 4 decimal places stops sounding like an ordinary distance fairly quickly. And there is a reason for that. Distances this large are not really measured the way a tape measure covers a room. They are worked out from tiny shifts in a star's apparent position as Earth itself moves around the Sunday. Shifts so small, they have to be teased out of years of repeated, careful observation rather than read off in a single glance. The method itself is called parallax, and it works on the same simple principle that lets a person judge distance by holding a thumb at arm's length and blinking one eye closed, then the other, blink between eyes, and the thumb appears to shift slightly against the far background, depending on which eye is doing the looking. Earth's own orbit gives astronomers exactly that kind of shift, only on a far larger scale. One eye's position in January and the other eye's position in July. 6 months and nearly 300 million kilometers apart. The size of that tiny shift, once carefully measured, is the entire measurement. A larger shift means a nearer star. A smaller shift means a farther one. And the relationship between the two runs in a simple, dependable inverse. Half the shift means twice the distance. A third of the shift means 3 times the distance, and so on. All the way out to shifts too small for any instrument yet built to catch at all. The unit astronomers built specifically to describe this, the parsec mentioned earlier, is defined directly from that geometry. It is simply the distance at which this same yearly shift would measure exactly one particular small angle, chosen once, long ago, to make the arithmetic clean. Everything about the unit traces back to the same thumb and eye trick, scaled up to the width of an entire orbit. For a star as close as Proxima, that shift, though still achingly small, is large enough to measure with modern instruments, and large enough that repeated measurements, refined over decades, have narrowed the resulting distance down to the confidence carried in 4 full decimal places. Farther stars show even smaller shifts, which is part of why distances to more remote points in the galaxy carry far less certainty than this one particular measurement does. In recent years, a dedicated space observatory has carried this same basic method further than any ground-based effort ever could, watching the whole sky repeatedly from a vantage point, free of the blurring and shifting caused by looking up through Earth's own atmosphere. The distances that mission has returned for the nearest stars, Proxima included, are among the most precisely known figures in all of astronomy. There is a gentler way to hold a number like this than simply repeating the decimals, and it is the one this journey will lean on for the rest of the walk. Light travels at a fixed, enormous speed, and a light year is simply the distance light covers crossing one full year at that speed. So 4.2465 light years is not really a length so much as a length built out of time. It describes how long a beam of light, moving as fast as anything can move, needs to make the crossing, which means something quietly unexpected about the light arriving from that direction tonight. The light reaching Earth from Proxima Centauri at this very moment left that star a little over 4 years ago. Whatever this walk eventually finds, there is already old news by the time anyone here gets to see it. You are always looking at the past of a star, never at the moment it is actually living through right now. A light year, then, is less a measurement of size and more a measurement of patience, a distance defined entirely by how long something moving at the fastest possible speed still needs to finish the trip. Nothing about it is a comment on how empty or how full that distance actually is. It is only a clock, stretched out and read as a length. Sitting with just how fast the thing doing the measuring actually moves is worth a moment, since the number only means anything once that speed feels real. Light crosses the distance from the Sunday to the Earth in a little over 8 minutes. It circles the entire Earth at ground level close to 8 times in a single second, and even moving that fast without ever slowing down for even an instant along the way, it still needs a little over 4 years, not 4 minutes or 4 days, to complete the walk this journey is making tonight. That is the plainest way to hold the whole distance in mind, not as a length at all, but as the answer to a very simple question. Asked of the fastest thing that exists, how long would it take the fastest possible traveler to make this crossing? 4 years and change. Nothing else in this walk, no rocket, no probe, no future spacecraft yet designed, will ever come close to matching that pace. Because a number carried to 4 decimal places is exactly the kind of detail that starts to feel like a fingerprint rather than a fact if it gets repeated too often. This walk will set it down here and then let it rest. From this point on, the distance to Proxima Centauri will simply be about 4¼ light years. Close enough for every purpose this journey needs, and gentler to carry for the rest of the night. It is worth naming gently what a distance this precise does and does not tell you. The distance tells you exactly how far the light has to travel, and exactly how long that travel takes. It does not, on its own, tell you what fills the space in between, whether that space is truly empty or carries some faint trace of material, or what the crossing would actually feel like to make in person rather than simply calculate on paper. Those are separate questions, and this walk will take them up one at a time, slowly in the chapters ahead. A number this precise can feel, at first, like it settles everything about the distance once and for all. In a narrow sense, it does. Widen the frame, though, and it is only the opening measurement of a much longer walk. The one figure this whole journey needed pinned down exactly before anything else about the crossing could be worked out with any confidence. The instrument responsible for the most recent, most exacting round of these measurements does its work in a way worth pausing on. Rather than watching one star at a time, it scans the entire sky repeatedly, over years, comparing each star's position against millions of others in the same pass, so that any tiny wobble one star shows gets checked against the steady backdrop of countless others, rather than against a handful of reference points chosen by hand. That cross-checking repeated endlessly is part of why the resulting distances carry the confidence they do. It is not one measurement trusted on faith. Millions of measurements, quietly checking each other's work, are closer to the truth. Numbers this size stop meaning anything on their own, so shrink the whole thing until it fits on a table. Picture an ordinary table, long enough to seat a family, and set a single grain of sand at one end of it to stand in for the Sunday. At that scale, everything else in this journey shrinks along with it, and shrinks by an enormous amount. Proxima Centauri, at that same scale, becomes another single grain, roughly the same size as the first, and that second grain does not sit anywhere near the far end of the table. It sits tens of kilometers away, out past the edge of whatever town the table happens to be standing in, further than a comfortable afternoon's travel, a separate grain of sand resting somewhere past the horizon. Picture standing at that table and actually setting off to find the second grain on foot. The walk would clear the table's edge in a single stride, and clear the room a moment later, and clear the building itself not long after that. It would keep going past the last house, on the street, past the edge of town, out along roads that stop being familiar, for as long as it takes to cover a true distance, measured in tens of kilometers, all to arrive at a single grain of sand, no larger than the one left behind on the table. Nothing about that walk would look, from the outside, like searching for a star. It would look exactly like an ordinary, very long walk to nowhere in particular, which is the entire point of building the model this way. Stand at that table for a moment and consider what sits nearby at this same tiny scale. The world you live on would be smaller than anything visible to the unaided eye, a speck too fine to separate from the grain standing in for the Sunday. Neighboring worlds, the next planet out, and the one after that, all the familiar neighbors of home would crowd invisibly close around that first grain, none of them straying more than a small fraction of an inch from where the model began. It is only once the model tries to reach the second star that the true shape of the distance finally shows itself. A model that fits the Sunday and every planet that orbits it onto a tabletop needs an entire town and the empty roads beyond it just to fit the walk to the very next star. Nothing about the inner part of the model, the crowded little cluster of planets near the first grain, prepares you for how much room the second half of the walk actually demands. Scale models like this one are a favorite tool of astronomers, precisely because raw numbers, spoken aloud, tend to blur together after a certain size. Millions, billions, trillions, they all start to sound roughly the same to an ordinary ear, even though the actual gap between them is enormous. Shrinking the whole system down to something a person could actually walk restores a sense of the distance that the numbers alone quietly lose. There is an old familiar version of this same kind of model that swaps the grain of sand for a basketball standing in for the Sunday and asks where the nearest star would then sit. That version tends to place the answer somewhere on the order of thousands of kilometers away, a distance that circles most of a planet. This walk has chosen the smaller grain instead, on purpose, because a model built at basketball scale stops being something a person could plausibly walk in an afternoon. And this whole journey has been built around the idea of a walk, not a flight. Whichever version gets used, the underlying lesson stays exactly the same. Change the size of the model, and the size of the gap changes right along with it. In exact, unbroken proportion. There is no way to shrink the Sunday down to something comfortable and keep the destination anywhere nearby. The two are locked together, and no amount of choosing a friendlier scale ever actually closes the real distance between them. That kind of honesty is exactly why scale models earn a place in an explanation like this one, instead of being treated as a mere trick for holding attention. A model that quietly cheated its own proportions, making the gap look friendlier than the numbers actually allow, would teach the wrong lesson twice over. A false sense of the true distance and a false trust in the model itself the next time it gets used. Keeping the grain and the gap honestly proportioned, tens of kilometers for a single grain of sand, is what lets this same table stand in for the real crossing without quietly lying about it. It is worth returning briefly to what this model is actually for. This model is not meant to make the walk feel shorter than it is. It is meant to make the walk feel real, translated out of units too large to hold in the mind, and into something closer to an ordinary afternoon sense of far. That is the whole and only purpose of shrinking anything down to a tabletop in the first place. Everything humans have ever built and sent outward, every spacecraft, every probe, every farthest object we have ever launched, still sits at this same scale within a hand's width of that first grain. The whole of human spaceflight, compressed down to this size, has not yet left the tabletop. That walk's midpoint, the place this whole journey is built around, is not simply across the room from where you started. On a scale this small, it is still a walk of hours, a real journey with a real middle, not a glance from one end of a table to the other. Distance does not stop being distance just because the ruler shrank. It is worth being honest about where this model's numbers come from, because not every figure in tonight's walk carries the same kind of certainty. The exact size of the grain and the exact distance it would sit at on a real table of a real length depends on choices about scale that are not themselves part of the measured astronomy. What matters and what stays true, no matter which exact numbers get chosen, is the shape of the thing, an enormous gap between two very small points, with almost nothing solid built by anyone ever leaving the immediate neighborhood of the first one. There is something worth sitting with in that image beyond the simple scale of it. Every rocket ever launched, every satellite, every crewed mission that has ever left the ground, all of it still belongs, in this small model, to the immediate area around the first grain of sand. The second grain, the one this whole walk is aimed at, has never once been reached by anything we have built, and on a model this size, it is easy to see exactly why. Even the farthest of our own instruments, the ones that have technically left every planet's orbit behind and drifted out into the dark on their own, remain on this same grain of sand table, close enough to the first grain to be measured in ordinary paces rather than in any longer unit. The gap they have yet to cross, to reach even the near edge of town, is still the overwhelming majority of the whole walk. None of that is a discouraging thing to sit with tonight. It is simply an honest one. The table and grain model is not built to make the crossing feel small. It is built to make the crossing feel real, honest about its own size. In a way, raw distances measured in unfamiliar units rarely manage on their own. Start walking, then the first thing you cross is not empty space. It is the Sunday's own weather. The Sunday does not simply sit in space, doing nothing beyond shining. It sends a steady outward stream of charged particles in every direction, a constant, quiet exhale that fills the whole neighborhood around it, long before any true starlight from elsewhere takes over. That stream has an edge, a real boundary where its influence finally gives out. Called the heliopause, that boundary sits at roughly 120 astronomical units from the Sunday. An astronomical unit itself being the distance from the Sunday to the Earth. Inside that boundary, the Sunday's own outward stream sets the conditions, pushing back whatever arrives from the wider galaxy. Outside it, that pushing simply stops, and the surroundings belong to something larger than any one star. The whole bubble carved out by that steady outward stream carries a name of its own. The heliosphere, a word built from the same root as the Sunday's own scientific name. Everything inside it, every planet, every moon, every scrap of dust still orbiting our star, spends its entire existence inside that one long, slow exhale, without any of it ever needing to think about where the bubble actually ends. Only 2 spacecraft so far have ever actually crossed that boundary and kept transmitting long enough to confirm what the other side looks like. Both were long-lived missions, launched decades ago, that simply kept traveling and kept working far longer than anyone building them had originally planned. Their instruments recorded a real measurable change right at the crossing, a drop in the outward pressure from the Sunday and a corresponding rise in the different kind of material found beyond it. That confirmation matters because until those 2 crossings, the exact location of the boundary was itself only a careful estimate, built from models rather than a direct measurement taken at the actual edge. Having real instruments pass through it and report back turned an educated guess into a genuine, measured landmark. The first hard data point on a walk that before that had relied entirely on calculation. It is worth noticing too that the boundary is not a perfectly even sphere. The Sunday moves through the wider galaxy the way any star does, and that motion presses the boundary in slightly on the leading side, while letting it trail out a little farther on the other, the whole shape closer to a blunt, elongated form than to a perfect ball. None of that changes the basic figure this walk is using, but it is a reminder that even a boundary this well-studied still holds real, unresolved detail once you look closely enough. The particular direction this walk is heading, roughly toward the bright triple system introduced earlier, is not necessarily the same direction as the Sunday's own leading edge through the galaxy, which means the exact distance to this boundary, along the specific line this walk is following, may run a little differently than the average figure carried so far. That difference is modest, not enough to change the shape of the story, only enough to remind a careful traveler that the boundary is a lived-in, textured thing rather than a tidy mathematical shell. There is something quietly grounding in learning that even the best measured boundary on this entire walk still carries some soft edges of its own uncertainty. Nothing about this journey has asked for false precision, and the heliopause, for all its careful study, is a fitting first reminder of that. A real, measured physical boundary, and also a gently uneven, imperfectly known one, both at once. It helps to think of it less as a wall and more as a handover. Nothing changes underfoot, in any dramatic way at that boundary. There is no line drawn in space, no gate, no visible marker. One authority over the local conditions simply, quietly, gives way to another, the way weather in one country gives way to weather in the next, without anything actually changing at the exact border itself. The crossing itself asks nothing dramatic of the traveler making it. No structure marks the spot, and nothing marks the change. It is a boundary of influence rather than of substance, the kind of edge that only shows up at all if something is actually measuring the conditions on either side of it and comparing notes. What actually gets measured at a crossing like this is worth being plain about, since the boundary itself is invisible to any eye. Instruments tuned to detect the density and motion of charged particles register a real sharp change right at the edge, a drop in the steady outward pressure coming from the Sunday, and a corresponding shift in the direction and character of whatever surrounds the craft. Afterward, that is the entire evidence for the boundary. Nothing about it could ever be seen directly, only measured. The outward stream doing all this work has a structure of its own worth a moment's attention, since it is not a single uniform gust, but something closer to weather in the true sense of the word. It gusts and eases, thickens and thins, rises and falls across the years in step with the Sunday's own longer cycles of activity, so that the boundary this walk is describing is not fixed in place so much as it breathes in and out over spans of years rather than sitting at one permanent distance forever. What this walk carries forward is the settled average of that breathing, not a single frozen instant of it. The Sunday's outward stream that builds this whole boundary in the first place is itself made of the same basic material found throughout the wider universe, protons and electrons, flung outward continuously from the Sunday's own outer layers, moving fast enough to cross the entire inner solar system in a matter of days. By the time that same stream has traveled all the way out to 120 astronomical units, it has thinned enormously, spread across a sphere so much larger than the one it started at that its remaining pressure finally gives out entirely against whatever the wider galaxy is pushing back with. Nothing about that outward stream is unique to the Sunday. Every star that has ever been closely studied appears to send out some version of the same steady exhale, a wind of its own, shaped by its own size and temperature and pace of spinning. Each of those winds, given enough room and enough time, carves out its own private bubble in the material around it, exactly the way the Sunday's has, so that the heliopause is not some special feature belonging only to home. It is simply the nearest example, once again, of something almost every star in the galaxy is quietly doing. Even at 120 astronomical units, this boundary sits astonishingly close to home by the standards of the rest of this walk. It is a landmark, the first true one on the road, but it is a landmark passed early, well before the harder part of the journey even properly begins. There is a plain, steady comfort available in thinking of the crossing this way as a series of quiet handovers rather than as a series of edges to be defended. The Sunday's own weather simply reaches this far and no farther, the way any given weather system on Earth eventually gives way to the next one over, without any sense of a border being crossed at risk. One set of ordinary conditions ends, and another equally ordinary set begins. Cross that line and you have left the Sunday behind. You have not, in any useful sense, gone anywhere. 120 astronomical units sounds like a great deal until it gets set beside the distance. This walk is actually covering. A light year is built from many tens of thousands of astronomical units, and the crossing to Proxima Centauri is more than 4 of those. The Sunday's own boundary, the first landmark passed, turns out to be a small fraction of a single light year, let alone the whole distance ahead. This is the first of several moments on this walk where a distance that felt enormous a few minutes ago quietly resets to something much smaller once a bigger ruler gets laid alongside it. Astronomical units are a perfectly good way to measure the neighborhood close to the Sunday. Comfortable and human in scale. The way describing a house in footsteps makes sense, right up until someone asks about the distance to the next town. A light year needs a completely different kind of ruler, one built not from a planet's own orbit, but from the pace of light itself. And once that switch happens, the whole earlier stretch of the walk collapses down to a rounding error. The heliopause, so carefully described a few minutes ago as a real measured boundary, still barely registers once. The scale shifts to the one this crossing actually demands. So the honest accounting here at the edge of what belongs to the Sunday is that almost none of the walk has actually happened yet. What felt, a few minutes ago, like real progress, an actual boundary crossed, an actual edge reached, turns out to be the first short stretch of a very long road, the kind of distance that barely registers against everything still ahead. There is nothing to worry over in that reset. It is simply the nature of a nested scale, the same kind of shift that happens when a map of a single neighborhood gets folded away in favor of a map of an entire continent. Both maps are accurate. They are simply built for different questions, and this walk has just traded one for the other. It is worth pausing on the phrase, many tens of thousands, since this walk will use it plainly, rather than reach for a false precision it cannot honestly support. The exact conversion between a light year and an astronomical unit is a fixed and well-known figure, but repeating it here as one more decimal-heavy number would only add clutter to a chapter whose real job is simply to convey scale, not to catalogue another exact value. Order of magnitude is the whole point here. Tens of thousands of the smaller unit fit inside just one of the larger one. That same relationship holds every time this walk moves from a smaller, more familiar unit to a larger, more patient one. An astronomical unit measures a comfortable, planetary kind of distance. A light year measures something built for the space between entire stars. Neither unit is wrong. Each one is simply suited to the size of question being asked of it. And this walk, having asked about the space between stars, now has to think in the larger unit for the remainder of the night. Even the smaller of these two units took patient generations to pin down with any real confidence. Long before any spacecraft could simply measure it directly, astronomers worked out the distance from the Sunday to the Earth by comparing careful observations of the same rare planetary alignment, taken from opposite sides of the globe, and quietly refined the answer across more than a century of these repeated attempts. The habit that pins down every distance in this walk, patient measurement, compared and rechecked, refined slowly rather than guessed at once, is not new to the light year. It is simply the same old habit, applied here to a much larger ruler. Every larger shell this journey reaches from here forward will ask the same quiet question again, in a slightly bigger voice each time, given how far the walk has already come, how much of it is actually behind you. So far, the honest answer keeps landing in the same place, very little. And that answer will keep holding, gently, patiently, for a while yet. This is not a discouraging pattern to notice, even though it might sound that way the first time it repeats. It is simply what an honest accounting of a very large distance looks like from the inside of the walk, rather than from a chart drawn after the fact. Nobody walking a real long road for the first time knows exactly how the milestones will feel until they actually reach each one. And this walk is no different, resetting its own sense of progress each time a bigger ruler gets laid alongside the last one. There is a plain, useful habit worth carrying forward from this particular chapter, since it will keep this walk honest at every remaining stop. Whenever a distance starts to feel conquered, worth pausing to ask what unit is actually doing the measuring, and whether a bigger one waiting just beyond it might reset the whole sense of progress all over again. That habit, more than any single number, is the real lesson this shorter chapter has to offer. This is worth naming plainly, because it is the same question this whole journey keeps returning to at every larger scale. If the ground already covered feels substantial and still barely counts, what does that say about the distance still remaining? The Sunday's boundary was the easy part. Almost the entire walk still lies ahead of it. It helps, at this point in the walk, to simply let the numbers go quiet for a moment and hold only the shape of the thing. A boundary was crossed. It mattered, and it will still matter later as this journey looks back on the whole crossing. Honestly though, it was also small, a first modest step on a road built from a much larger unit of measure entirely. Both of those facts can rest together without contradiction. There is a plain, almost architectural way to picture this nesting of scales, if numbers alone do not quite settle it. Think of the walk so far as the first room of a very large house, fully real, fully furnished, entirely worth the time spent in it, and still only the first room. Nothing about calling it small takes away from how real it was to walk through. It only says, honestly, how many more rooms this particular house happens to have. And that stretch that belongs to nobody is not the nothing it is usually drawn as. Cross the Sunday's boundary, and the ordinary picture most people carry is of a true vacuum from there on, a stretch of nothing at all until the next star's own boundary finally begins. That picture is not quite right. The material filling the space between stars, called the interstellar medium, holds roughly 1/10 of an atom in every cubic centimeter. On average, in this part of the galaxy, that is an almost unimaginably thin presence, far emptier than any vacuum ever produced inside a laboratory on Earth. And still, thin as it is made of something. It is not the perfect emptiness the word vacuum usually suggests. Holding that figure against something built by hand helps. The best vacuum chambers built on Earth, the ones used to test spacecraft parts or grow delicate materials free of contamination, can pump a space down to a density far lower than ordinary air, impressively thin by any Earthbound standard. And still, the quiet material drifting between the stars, spread thin across the whole crossing, is emptier again than even those careful, engineered chambers manage. That material is not evenly one single thing, either. It is mostly hydrogen, the simplest, and most common element in the universe, with a small admixture of helium and a scattering of heavier atoms, mixed faintly through it. The same rough recipe found almost everywhere else in the galaxy, simply thinned here to a whisper. Astronomers map its distribution by watching how faint background starlight is very slightly altered on its way to us, absorbed and shifted in tiny specific ways by the handful of atoms it happens to pass on the journey. Threaded quietly through that same thin material is a magnetic field of its own, far weaker than anything a compass on Earth would ever notice, yet real enough to gently nudge the path of the charged particles drifting through it, curving their motion in slow, wide arcs rather than letting them travel in perfectly straight lines. Astronomers trace that faint field the same patient way they trace almost everything else out here, indirectly, by watching how it subtly organizes the dust and gas around it into long, faint filaments, rather than by ever touching or seeing the field itself. Pockets of this same neighborhood are not even uniformly cold. Some patches, heated long ago by the shockwaves of ancient stellar explosions, far outside this particular crossing, drift at surprisingly high temperatures, despite carrying almost no material at all. Proof that heat and density are not the same question out here, any more than nearness and visibility were back at the start of this walk. Other patches stay quiet and still, closer to what most people already picture when they imagine the space between the stars. The crossing to Proxima happens to pass mostly through one of the calmer, quieter pockets, which is part of why this walk has been able to speak of it in such an even, settled voice. Density itself is not perfectly uniform across the whole crossing, either. Some patches of the space between the stars carry a little more material than others, thin clouds and thinner voids within the same general average. The way weather on Earth carries real variation, even while the overall climate stays broadly the same from year to year. The 1/10 of an atom per cubic centimeter figure is an average taken across a great deal of this uneven texture, not a fixed reading true at every single point along the way. It helps to hold both halves of that fact at once, rather than letting one crowd out the other. This material is thinner than anything human engineering has ever managed to create on purpose, and it is not nothing. Both things are true together, and neither one cancels the other out. Over a crossing this long, even a whisper of material, this thin adds up into something real, a genuine presence, rather than a rounding error. It is not enough to slow anything down in any way that matters, and it is not a hazard to be avoided. Simply, quietly, it is there, the whole way across, thin the whole way across, and never once truly absent. It is worth being plain about what this thinness means for anything actually making the crossing. A spacecraft moving through this material feels essentially nothing from it. No meaningful resistance, no measurable slowing. Nothing a passenger, if one could somehow be aboard, would ever notice as friction or drag. The material's real significance is not mechanical. It is simply that it settles, once and for all, the old, tidy idea of a perfect vacuum lying between every star and its neighbors. Astronomers first suspected material like this existed long before any spacecraft could confirm it directly. From careful study of how starlight passing through long stretches of space arrived very slightly dimmed and very slightly reddened compared to what a truly empty path would produce. That subtle discoloration spread across enormous distances, was the first hint that something, however faint, was quietly filling the space every star's light had to cross to reach us. Later, direct measurements taken by instruments that had actually crossed into this material confirmed what the earlier indirect evidence had already suggested. The density readings matched, the composition matched, and a picture built for decades entirely from starlight finally had a spacecraft's own instruments standing beside it in agreement. Few results in this kind of long-distance astronomy get that particular kind of confirmation, a careful prediction, and a direct measurement meeting in the middle. So the picture to carry for the rest of this walk is not a hard vacuum and not a crowded, misty gas either. It is somewhere quietly between the two, real material, spread so thin that calling the space between the stars empty is technically wrong, even though calling it crowded would be just as wrong in the opposite direction. Alongside the drifting gas, the same stretch of space carries a faint rain of far more energetic particles, individual atomic fragments flung outward by distant, long past stellar violence, and by the Sunday's own quieter activity, crossing the gap at speeds close to that of light itself. These are usually called cosmic rays, though the name is older than the understanding of what they actually are, and they arrive from every direction at once, rather than from any single source a traveler could simply avoid by choosing a different path. Like the thin gas itself, they are far too sparse individually to be felt as anything, a fact rather than a sensation, one more quiet ingredient in a crossing that keeps turning out to be less empty at every scale than the word vacuum ever promised. This same thin material, spread across the whole galaxy rather than just this one crossing, is also where new stars eventually gather from. Given enough time and enough patient accumulation across a large enough region, some of this same faint, scattered material slowly draws together into denser clouds, and some of those clouds eventually collapse into the beginnings of new stars entirely. What fills the gap this walk is crossing tonight is not simply left over from something older. It is also, in its own unhurried way, the raw material for what comes next. There is something quietly fitting in that fact for a walk built around a single particular crossing. The material this journey has been moving through the whole time is not simply the leftover backdrop to two specific stars. It is part of a much longer, much larger, much slower story, one that connects the space between the Sunday and Proxima Centauri to the wider history of every other star this same thin material has ever helped build. There is a kind of quiet company in that fact. The distance between the Sunday and its nearest neighbor is not a true void, not an absence of everything, but a long, thin stretch of something, however faint, the whole way through. Walk that thin material for 2.12 light years, and you arrive at the only place on this road with a name we gave it. Here, at last, is the place this entire walk has been walking toward. The exact midpoint of the crossing, about 2.12 light years out from the Sunday, and about the same distance, still remaining ahead to Proxima Centauri. Stand here in the middle of the gap and look both ways. Everything this walk has covered so far, the invisible neighbor, the bright triple system, the precise distance, the table-sized model, the Sunday's own boundary, the thin material filling the gap, all of it was preparation for exactly this one spot. Nothing about the ground already covered changes here. What changes is simply where you are standing, and what that particular vantage point finally lets you see. Look back the way you came, and the Sunday is still there, easily the brightest star in that whole sky. From this midpoint, the Sunday shows an apparent magnitude of about -1.1, roughly as bright from here as Sirius appears from the ground back on Earth. It is not a faint smudge on the way to disappearing. Clear, steady, unmistakable, it remains the single brightest thing visible in any direction. Look ahead, the way you are headed, and Proxima Centauri. The whole reason for this walk shows an apparent magnitude of about 9.7. That is still far below the naked eye limit of about magnitude 6. Having covered exactly half the distance, having walked precisely as far as there is left to walk, the eye alone still cannot find the destination. It is there, simply still too dim to see. Both of those numbers come from the same simple arithmetic, applied to two very different starting points. Every star has a true brightness, how much light it actually puts out, and an apparent brightness, how bright it happens to look from any particular distance. Move the observer closer or farther, and the apparent number changes accordingly, predictably, while the true brightness underneath it never does. Standing at the midpoint simply means plugging in a new distance for each of these two stars, and reading off what the sky would actually show from there. The Sunday's true brightness is considerable, easily enough to remain the sky's dominant point, even after 2.12 light years of thinning. Proxima's true brightness, as this walk will explain fully in a later chapter, is modest by comparison, small enough that even cutting the whole remaining distance in half still leaves it short of what an unaided eye can gather. Two very different stars, given the exact same test, and two very different results. Astronomers keep these two ideas, true brightness and apparent brightness, carefully separated with their own pair of terms, one describing a star as it actually is, and the other describing only how it happens to look from one particular vantage point. Every apparent magnitude named so far tonight, Proxima's 11.1 from Earth, the naked eye limit of about 6, and now these two fresh numbers from the midpoint, belongs to that second vantage-dependent category. Move the vantage point, and only that second number changes. The star underneath it never does. Say the whole of it plainly, because this is the beat the whole walk has been built toward. Half the distance is behind you, and the destination is still, to your own eyes, not there at all. Being exactly halfway changes nothing about whether you can see where you are going. It only changes how far you have come. That is the whole claim this episode set out to make, back at the very start. And it is worth letting it simply stand here for a moment. Unadorned, no twist follows it, and no further reveal changes it. It is exactly what it appears to be, a plain, measured fact about two stars and the precise middle of the distance between them. Quietly stranger than it first sounds, and no more dramatic than that. There is no drama needed around a fact this quiet, and none will be added here. Sit with it exactly as it is. A traveler standing at this precise point, with nothing but their own eyes to work with, would navigate the whole remaining walk the same way they navigated the first half, by looking behind them, at the one light source that has never once stopped being the brightest thing available. Let the two numbers simply sit side by side for a moment, without reaching for either one to explain away the other. -1.1 behind you, 9.7 ahead. One, a comfortable, familiar presence. The other, a modest star waiting patiently to be reached, neither number asking anything more dramatic of you than to be believed exactly as measured. It is worth being precise about why this happens, since the two numbers involved are telling two very different stories about two very different kinds of star. The Sunday, seen from 2.12 light years, is still bright mostly because the distance, while large, has not yet grown large enough to fully overwhelm how much light a star like the Sunday puts out. Proxima, as this walk will explain more fully soon, is simply a much fainter kind of star to begin with. Dim enough that even half the full crossing is not nearly enough distance to bring it into naked eye range. It is worth imagining, too, what this same midpoint would look like if the two stars happened to be reversed, the fainter one behind and the brighter one ahead. In that version of the walk, the destination would already be climbing into view well before the halfway mark, and the star behind would be the one fading from notice early. Nothing about the geometry of this crossing forced the particular arrangement. This walk actually has. It simply happens that the brighter of the two stars is the one already left behind, and the fainter one is the one still waiting ahead. That small thought experiment is worth holding for a moment, because it makes plain that nothing about tonight's particular arrangement was guaranteed. Some pairs of neighboring stars would light a traveler's way home and dim the road ahead into mystery. Others would do the reverse, brightening steadily toward the destination the whole way out. This crossing simply happened to draw the first version, home lit, ahead quiet, and that accident of arrangement is the whole reason this walk has anything worth noticing to say about looking both ways from the middle. That particular arrangement, brighter behind, fainter ahead, is worth carrying forward as this walk's own quiet signature. The one detail that makes this specific crossing different from any other pair of neighboring stars a traveler might have picked. Instead, some crossings would light up gradually the whole way. This one holds its answer back until very near the very end. That is worth carrying as this chapter's one quiet takeaway. Separate from either number alone, a walk can be exactly halfway finished by every honest measure and still not feel halfway finished to the traveler making it, simply because of which star happens to be doing the shining. Distance and appearance keep agreeing to disagree the whole night through, and this spot, right at the middle, is where that disagreement shows most plainly. Turn around from out here at the midpoint. Home does not vanish, it simply changes into something smaller and plainer than it has ever looked from anywhere nearer. Every planet that has ever been named, every moon that has ever been mapped, every comet that has ever swung close enough to be tracked by a patient astronomer, all of them still orbit that one small point, exactly as they always have, entirely unaffected by how far away a traveler happens to be standing to look back at them. Distance changes how something looks. It does not change what it is doing. Consider for a moment everything still quietly circling that one point right now. At whatever moment this walk happens to reach the midpoint, worlds keep turning on their own axes. Moons keep tracing their own smaller loops around their own worlds. None of that ordinary business pauses to notice a traveler, 2 light years out, looking back at it. The whole familiar arrangement is simply going on, exactly as it always has, indifferent in the gentlest possible sense to who happens to be watching from how far away. At an apparent magnitude of about -1.1, the Sunday from this distance is the brightest star in that sky. And nothing more than a star, a point of light, not a disk, a star, not a sun. The category itself has changed, quietly, somewhere along the walk, without any single dramatic moment marking the exact place it happened. That change is worth sitting with carefully because it is easy to reach for the wrong feeling around it. Nothing has been lost here. Everything the Sunday has ever done, everything anyone has ever built, or grown or lived by its light, is still folded entirely into that one small point. The point simply looks smaller from farther away. It has not become less. The easy mistake, standing at a spot like this for the first time, would be to read shrinking as a kind of quiet subtraction. One more thing growing smaller the way things do when they are being left behind for good. This walk asks for a gentler reading instead. A point does not need to fill the frame to still hold everything it has ever held. Size, out here, was never really standing in for importance. It was only ever standing in for distance. The same shift happens on a far smaller scale every time someone leaves a familiar room and glances back from down the hallway. Nothing in the room changes. The lamp inside it does not dim. Only the angle and the distance change, and the eye reads that change as smaller, plainer, less filling of the view, when nothing about the room itself has actually shifted at all. The midpoint simply applies that same familiar experience to an entire star. It is worth naming, too, what this chapter is not claiming, nor is it claiming that the Sunday has grown weaker, or that its light has thinned in any meaningful sense by the time it reaches this exact spot. The light reaching this precise point is still the same light, still carrying the same underlying brightness, simply spread, as all light spreads, a little further across a slightly wider sphere than it was back at Earth's own more familiar distance. And it is still, by a wide margin, the easiest thing to find in the whole sky from here. Every other star nearby fades into the same general scatter of cold background light. This one alone stands apart, obviously immediately. The one-pointed traveler standing at this exact spot would find first, every single time, without needing to search. There is an old, practical habit among people who spend real time under open sky, sailors on long crossings, travelers on foot through country without landmarks, that leans on exactly this same quality. Find the one steady, reliable point first and orient everything else around it, rather than trying to hold the whole unfamiliar sky in mind at once. The Sunday, from this midpoint, is doing precisely that job for anyone standing here, whether or not they ever think of it in those terms. A steady point does not need to be large or near to be useful. It only needs to be dependable. That kind of easy recognition matters more than it might first seem. Out on a walk this long, a sky full of unfamiliar, equally faint points would offer nothing to orient by, no landmark, no fixed reference a traveler could return to again and again. The Sunday's continued brightness, even reduced to a single point, keeps offering exactly that, one dependable thing in an otherwise unfamiliar sky. It would be simple to let this chapter slide towards smallness and toward a story about distance overtaking everything familiar. That is not the shape of what is actually happening here. The line worth carrying forward is a plainer, steadier one. Home is still the brightest thing you can see. Not vanishing, nor fading past finding. Simply, honestly, a star now doing from this distance exactly what a star does, which is a change in category, not a disappearance. Every traveler who has ever made a long crossing of any kind knows some version of this same reassurance. the one fixed point that keeps its shape, no matter how far the journey carries you from it. A harbor light shrinks as a boat pulls away without ever once going out. So does a childhood house, growing smaller in the rearview mirror without ceasing to be the house. Distance narrates smallness convincingly, and it is, in every one of these cases, telling only part of the story. There is something worth noticing in how little effort it takes, even from here, to keep finding that one point again and again. A traveler retracing this same walk 1,000 times over would never once lose track of which direction home sits in. The brightness itself becomes a kind of constant, something steady to return to, however far the rest of the walk still has to go. Compare that, for a moment, to the destination waiting somewhere ahead, still nameless to the eye, still indistinguishable from any other faint smudge a traveler might glance past without noticing. One direction offers instant, effortless recognition. The other offers none at all. Not yet. That asymmetry, familiar behind and unfamiliar ahead, is not a flaw in the walk. It is simply the ordinary shape of being partway through any long crossing. Home still easy, the far shore still earning its own recognition slowly. Now turn back the way you were headed. Ahead, the destination is still not there, at least not to the eye alone. At an apparent magnitude of 9.7, Proxima Centauri needs more than any unaided human eye can gather. It needs light collected over time, the kind of patient collecting that only a telescope or a long camera exposure can manage. Standing here at the exact midpoint, with nothing but your own eyes, the star this whole walk is named for remains invisible, exactly as invisible as it was back at the start. A camera given long enough would manage what the eye alone cannot, holding its shutter open and quietly stacking faint photons one after another until enough of them have gathered to register. The eye has no such patience built into it. It reads the sky fresh every fraction of a second and discards what it just saw, which is a wonderful trick for catching motion and useless for catching faintness. Proxima is not hiding from the eye out of any real concealment. It is simply asking for a kind of patience no eye was ever built to offer. There is a kind of quiet symmetry worth noticing here, one that closes a loop this walk opened all the way back at the very beginning. From Earth, Proxima sat at magnitude 11.1, well beyond the naked eye limit. Having closed half the distance, it now sits at magnitude 9.7 from the midpoint, brighter, measurably brighter, and still on the wrong side of the same line. Having the distance did not have the problem. It only moved the goalpost a little closer without actually reaching it. That is worth sitting with plainly, because it says something true about how brightness and distance actually relate to each other. Cutting a distance in half does not cut its effect on apparent brightness in half to match. The relationship is steeper than that, which is part of why even a traveler who has already walked exactly as far as remains still cannot claim the easy reward of finally seeing the destination. Light spreads outward from any star, the same patient way a ripple spreads outward across still water, covering an ever-widening area with the same fixed amount of light, so that a given patch of sky receives a shrinking share of it the farther the patch sits from the source. Halve the distance, and the light does not simply double. It gathers over a much smaller share of the sphere, it would have spread across at the old distance. So the brightness climbs faster than the simple halving would suggest. That steepness is exactly why Proximas climb from magnitude 11.1 to 9.7, while real still falls well short of closing the whole gap in one clean move. Ahead, though, the sky is not truly empty either. The bright pair, Alpha Centauri A and B, are visible from here, closer now than they were from Earth, and correspondingly brighter, a clear and obvious presence in the direction this walk is heading. So the sky in front of you is not blank, it simply is not showing you your actual target. What it is showing you instead is the star's much brighter neighbors, the ones that were never the real destination to begin with. This is a second, quieter version of the very same confusion, this walk named back at the start of the journey, the bright thing that draws the eye standing in, for the fainter thing that is actually being sought. Only now the confusion has a real physical shape to it. The bright pair genuinely does sit nearby, in almost the same direction, and genuinely does grow larger and easier to see the closer this walk gets. It has simply never been, and will never become, the actual reason for the walk. How easy a mistake that would be to make. Walking this road for real is worth pausing on, looking ahead, seeing two obvious bright points growing steadily larger. It would be simple enough to mistake that pair for the finish line and never notice the quieter, dimmer target still hiding somewhere near them. The bright thing ahead and the true destination are, this whole walk, two different objects occupying roughly the same patch of sky. Proxima only climbs into a brightness the naked eye could manage late in the second half of this crossing, well past the point this walk has currently reached. For now, and for a good while yet, ahead remains, to the eye alone, mostly a story about somebody else's light. There is something worth sitting with in how gradual that climb actually is. Brightness, as this walk keeps discovering, does not arrive all at once. It builds slowly, the same shrinking distance, buying a little more visibility with every step, right up until the final stretch, when what was always there simply crosses, at last, into a range the eye can finally register. Nothing changes about Proxima itself along the way. Only the gap between here and there keeps closing, patiently the same way every other distance in this walk has closed. It is worth noticing, gently, how much of this entire walk has turned out to hinge on exactly this kind of distinction. The visible standing in for the actual, the bright neighbor standing in for the true target. The confusion happened at the very beginning, with the whole triple system. It happens again here, at the midpoint, looking forward. The lesson, if there is one worth naming, is simply to keep asking which star is actually being looked at, and which one merely happens to be easiest to see. That habit of double-checking which star is actually being looked at is not really about astronomy at all, if it helps to say so plainly. It applies just as easily to anything bright enough to draw attention on its own. A habit worth carrying well past tonight's particular walk. Notice what is easiest to see, and then ask gently whether it is also the thing actually being sought, or only the thing standing conveniently nearby. There is a plain, quiet shape starting to form here, though this walk will hold off on stating it outright a while longer. For the whole of the walk so far, what has actually guided a traveler standing at this spot is not the thing ahead, it is the thing behind. That is worth simply noticing for now, and carrying forward rather than resolving all at once. Keep walking anyway. It is worth knowing what is waiting. The far end of this walk holds a star that turns out to have a family of its own, small and quiet, and easy to miss if you are only watching for something dramatic. Proxima Centauri is a red dwarf, spectral type M5.5 VE, one of the smallest and coolest true stars known. It carries roughly 12% of the Sunday's mass and about 15% of the Sunday's radius, and its surface runs at a temperature of around 3000 Kelvin, far cooler than the surface of the Sunday. On any chart of stars sorted by size and temperature, it sits near the very bottom of both scales. Red dwarfs of this kind are by a wide margin the most common type of star in the galaxy, far outnumbering stars built more like the Sunday. Most of the stars filling the sky on any given night, in other words, are simply too dim for that same abundance to register to the unaided eye. Proxima is not an unusual kind of star. It is an extremely ordinary one, made unusual only by happening to sit nearer than any other example of its own common type. Walk that thought all the way out, and something quietly reorients itself. The kind of star most people picture when they picture a star, bright, golden in the old warm sense, easily seen, is closer to the exception across the galaxy than the rule. Small, cool, and dim, mostly invisible from any great distance, is closer to the rule, exactly the description that kept Proxima itself hidden from every naked eye chart ever drawn. The night sky, for all its familiar bright points, is quietly built mostly out of stars nobody has ever managed to see without help. Stars this small burn through their available fuel with remarkable patience, far more slowly than a star like the Sunday, which means a red dwarf like Proxima has a projected lifespan measured in a span of time far longer than the current age of the universe itself. Whatever else changes across this walk's long timescales, Proxima itself is, by stellar standards, only just getting started. Small and cool as it is, Proxima is not a still or silent star. It brightens suddenly and often, flaring in ways far more frequent and more dramatic relative to its own size than anything the Sunday produces. Astronomers call stars that behave this way flare stars, and Proxima is one of the more restless examples known. Its light is not a steady, unchanging glow. It rises and falls, sometimes sharply, on a schedule nobody outside can fully predict. These flares come from the same basic kind of magnetic activity. The Sunday itself carries, only scaled up considerably, relative to how faint the underlying star normally runs. A flare capable of only modestly brightening a star, as large and steady as the Sunday can. For a small dim star like Proxima, briefly double or more than double its usual output, a dramatic change in relative terms, even though the absolute amount of extra light involved stays fairly small by stellar standards. Astronomers who study Proxima closely have learned to expect this restlessness as simply part of the star's ordinary character, the way a particular river might be known for running faster after rain. It is a known, catalogued, well-studied behavior, not a surprise, and not, on the timescale this walk has been measuring everything else by, a change in the star's fundamental nature at all. Around that restless, lively little star, at least 2 worlds are known to orbit. Proxima b carries roughly 1.07 times the mass of Earth, circling its star every 11.19 days at a distance of about 0.049 astronomical units. Close enough, given how faint and cool Proxima itself runs, to sit inside the star's habitable zone, the band of distance, where conditions could in principle allow liquid water. A second confirmed world, Proxima d, carries roughly 0.26 times the mass of Earth, smaller still, and orbits even closer in, sometimes called Proxima c. A third possible world remains an unconfirmed candidate rather than a settled discovery, and this walk will treat it exactly that way. A candidate not yet, a confirmed member of the family. Neither confirmed world has ever actually been photographed directly. Both were found the same patient, indirect way distant planets almost always are, by watching the star itself for the faint rhythmic wobble a small orbiting mass tugs into its motion, or for the tiny periodic dimming a planet causes as it happens to cross in front of its star's own light. What is known about each of these worlds is a careful inference built from that wobble and that dimming, not a picture taken up close. The wobble itself is a small thing to chase. A planet does not simply circle its star while the star holds perfectly still. Both bodies actually swing around a shared point between them, the star's own share of that motion shrinking as the planet's mass shrinks, until, for a world as light as Proxima b, the star's answering tug becomes a vanishingly small back and forth in its light, teased out only by measuring the same star, patiently, night after night, for years. It is the same discipline that pinned down the distance to Proxima itself in the first place, applied here to a motion smaller still. Because Proxima b sits within the habitable zone, the band of distance at which a rocky world could, in principle, hold liquid water on its surface. It has drawn a great deal of careful attention since its discovery. Being in that zone is not the same as being confirmed to actually hold water, or an atmosphere, or anything else beyond the bare orbital facts already measured. It is an invitation to keep watching closely, not a settled conclusion. There is something worth sitting with for a moment in how unexpected it is that the nearest star to our own turns out to carry a family of small worlds of its own, one of them sitting in the same rough band of distance relative to its star where our own Earth sits relative to the Sunday. Nearness and ordinariness, it turns out, are not connected either. The nearest system is not a simple, empty, lonely point of light. It has structure and company of its own. None of this changes anything about the earlier part of the walk. Proxima remains too dim for the unaided eye at the midpoint, and it remains too dim for the unaided eye from Earth as well. Its family of small worlds does nothing to change how much light the star itself puts out into the surrounding dark. Being interesting up close and being visible from far away turn out, once again, to be two entirely separate questions, all of which raises the only question the walk has been avoiding. How long would this actually take? Nothing built by human hands has ever traveled faster, relative to the Sunday, than Voyager 1, and even that speed does not come close to making this walk quick. Voyager 1 moves at roughly 17 kilometers every second, a speed that would carry it around the entire circumference of the Earth in well under an hour. Out here, spread across the true distance of this walk, that same speed stretches into something closer to a crawl. At 17 kilometers a second, reaching Proxima Centauri outright would take something on the order of 75,000 years. The stretch from the Sunday to this walk's own midpoint on its own would already take tens of thousands of years at that pace. It helps to hold that speed against something more familiar before letting the bigger number sink in. 17 kilometers a second is genuinely fast, fast enough to make the fastest vehicles built for use on Earth's own roads and runways look like they are standing still by comparison. Voyager earned that speed the patient way, borrowing a little momentum from the gravity of each planet it passed on its way outward, a careful decades-long trade of one gravitational assist for another rather than any single burst of power. The instrument that actually confirmed the crossing this walk described earlier. The moment the craft passed from the Sunday's own outward stream into the quieter material beyond it, was not a camera and was never meant to take a picture of anything. It was built to listen. A plasma wave instrument, a pair of long, thin antennas trailing from the craft's own body, tuned to catch the faint natural oscillations that charged particles make as they jostle past each other in the surrounding material. Cameras cannot see a boundary this thin, listening for a change in pitch, in that faint natural hum. It turned out, could. What that instrument actually heard once the crossing happened was a rise in pitch, the natural oscillation of the surrounding material, ringing at a noticeably higher note than it had inside the Sunday's own bubble. Exactly the signature a denser, colder, interstellar plasma would produce compared to the thinner, hotter material closer to home. It was a small, quiet sound, gathered from a whisper of static most instruments would have dismissed entirely, and it became the clearest single piece of evidence that the crossing had actually happened, more convincing in its way than any of the particle counting instruments sitting right beside it. Alongside that listening instrument, the craft has carried, for its entire long journey, a small suite of others built to count particles directly, to measure the strength and direction of magnetic fields too faint for any earthbound sense to register, and, in its early years, to photograph the planets it passed on the way out. Those cameras were switched off decades ago now, their work long finished, leaving the quieter instruments, the ones built to listen and to count rather than to look, as the only ones still occasionally reporting home. Set that same speed against the distance of this crossing, and the crawl becomes plain. 75,000 years is longer than the whole of recorded human history, repeated many times over. Languages would rise and fade, and be replaced by entirely new ones, several times across. In the time this one small craft would need to finish the crossing at its current pace. It helps, briefly, to hold that same span against something closer to home rather than something as abstract as an entire language rising and fading. Proxima's own outermost known world, Proxima D, completes its own tight orbit many, many times within a single one of Earth's years. In the time this same small craft would need to finish this one crossing at its present pace, that inner world would have completed more laps around its own star than any traveler could easily hold in mind at once. A small, fast, patient rhythm repeating itself far longer than the crossing that would finally bring a visitor close enough to watch it. It is worth stating plainly, because it is easy to assume otherwise. Voyager 1 is not aimed at Proxima Centauri. Nothing we have built is headed there. The craft is simply moving outward, in a direction that happens to carry it. Eventually, somewhere in the general neighborhood of that part of the sky, on a timescale that has nothing to do with any destination at all. None of humanity's other far-traveling craft are aimed there either. Each was sent outward toward a particular planet, a particular flyby, a particular question about this one solar system, and each simply kept going once its actual assignment was finished, carried by whatever direction its last planetary encounter happened to leave it facing. Proxima Centauri has never once been anybody's actual target. It has only ever been a direction a few of these craft happened to be loosely wandering toward, by accident of trajectory rather than by any design. Voyager 1 launched decades ago and has, by now, crossed the same boundary this walk crossed earlier, the Sunday's own edge of influence, and kept going. Its instruments, one by one, have begun to fall quiet as its power source slowly runs down, and at some point, not too many years from now, its signal will end for good. It will not stop moving, only stop talking, and coast on afterward, carrying its own small momentum outward, long after anyone on Earth is still listening for it. The craft carries a small, careful power source that converts a slow, steady decay of material into electricity, enough to run its instruments and its radio for an unusually long stretch of decades, far longer than its original mission ever called for. That supply thins gradually rather than suddenly, which is why the instruments aboard have been switched off one at a time, in careful sequence, rather than all at once. Each shut down a small, deliberate choice made to stretch the remaining power a little further. Even once the last instrument finally falls silent, the craft itself keeps moving, unchanged in its course, carrying a small engraved record of home outward with it, regardless of whether anyone is still listening. That record holds a careful selection of ordinary Earth sounds and images and greetings, chosen with real care by the people who built the mission, addressed to nobody in particular and everybody at once, riding along on a craft that was never actually aimed at any of the stars it might eventually drift near. This onward drift is not really a continuation of the mission in any working sense. It is simply what an object in motion, with nothing left to slow it down, keeps doing, quietly, for as long as there is anywhere left to go. None of that changes its course, and none of it brings the craft any closer to Proxima Centauri than a straight patient line already carries it. Even carrying on, undirected for longer than any instrument aboard, it will still be reporting back. The numbers involved stay the same. 17 kilometers a second is fast by any standard measured on Earth, and it is nowhere near fast enough to make a crossing this size feel quick, which sounds like difficult news, and is not. It is only the wrong way to hold the number. Here is the plainer way to hold everything this walk has covered. Stars are spaced roughly this far apart everywhere, across this part of the galaxy. The distance covered tonight is not some particular misfortune belonging to our own Sunday. It is the ordinary condition of the neighborhood, repeated with only small variations, star after star after star. Picture, for a moment, the whole galaxy at once, rather than just the one small crossing this walk has been measuring. Every star in it keeps roughly this same kind of distance from its nearest neighbors, some closer, some farther, but almost none of them crowded in any way that would feel, to a traveler, like true closeness. The gap between the Sunday and Proxima Centauri is not an unusual gap. It is close to the typical one, the ordinary spacing this entire part of the galaxy quietly keeps. That spacing is not an obstacle to be regretted. It is, in fact, part of what keeps everything stable. Orbits, once settled, stay settled for the hundreds of thousands of years it takes something like Proxima to complete, even a single lap around its own bright neighbors, precisely because nothing else nearby is close enough to disturb them. Room out here is what lets things last. The same principle holds at scales, far smaller than a whole galaxy. If it helps to bring it back down to something closer at hand, a room with a little more space in it is easier to move through calmly than one crowded wall to wall. So is a schedule with a little slack built into it, surviving an unexpected delay better than one packed edge to edge. None of that is a perfect match for the physics of stellar orbits, but the underlying shape of the idea travels well. Distance, held in the right proportion, is not the enemy of stability. It is very often the reason stability is possible at all. A galaxy built with its stars packed more tightly together would be a far less settled place. Its orbits tugged and reshaped by frequent close encounters. Its long, patient arrangements interrupted long before they could ever stabilize into anything lasting. The roomy spacing this walk has spent the whole night crossing is not incidental to how calm the galaxy actually is. It is, in a real sense, the reason for that calm. Denser neighborhoods of stars do exist elsewhere across the galaxy. Tightly packed clusters where crowding really is the ordinary condition, rather than the exception. And the systems that form there tend to carry a more chaotic, more frequently disturbed history as a direct result. The Sunday and its neighbors, by comparison, sit in a comparatively quiet, comparatively roomy stretch of galactic suburb, the kind of neighborhood where a triple system like Alpha Centauri and Proxima has been left largely undisturbed for as long as it has existed. Roominess, in other words, is not a universal galactic constant. It is a local condition, and this walk has been fortunate enough to cross one of the calmer versions of it. There is a comfortable echo here of the same idea this walk keeps returning to at every scale. Distance is not the same thing as absence, and room is not the same thing as loss. The gap between the Sunday and Proxima Centauri gave this whole crossing its length. It also gave both stars, and everything quietly orbiting each of them, the patient stability that only that same length of room can provide. And here, finally, is the answer this whole walk has been circling since the very first minute. For the entire first half of the crossing, a traveler making this journey steers by the Sunday because home stays the brightest thing in the sky for that whole stretch. Not seeing where you are going is not a failure of the walk. It is simply what the middle of a crossing this size looks like, the ordinary condition of being partway there, rather than any kind of problem needing to be solved. There is a kind of rest in understanding it this way, rather than as an absence. The gap is not a stretch of nothing to be endured. It is room, plainly and simply, the same room every star in this part of the galaxy is given, the same room that keeps every one of these long, slow, patient orbits from ever running into each other. Carry that reframe past tonight's particular walk, if it helps, since it was never really only about these two stars. Room shows up as the quiet, load-bearing feature behind a great deal of what this walk found calm rather than crowded. The roomy triple system that let three stars share a family without disturbing each other's long orbits. The roomy boundary the Sunday keeps around itself without needing to defend it. The roomy, thin material filling the gap without ever thickening into anything that would slow a traveler down. Distance, held loosely rather than gripped as a problem, kept turning out to be exactly what let each of these things settle into something lasting. And all of it is going on above your roof right now. Somewhere above you, right now, the same sky is turning the way it always turns, carrying that same small, dim, nearest star through the same slow orbit it has been keeping for longer than anyone has been alive to watch it. This is the same roof this whole walk started under, and the same sky looked at once more, now that a little more of it has a name attached. Nothing about the view itself has changed since the very first minute of tonight. Only the person looking up at it has carrying home now, quietly, one extra fact about one extra patch of dark. You still cannot see it. That has not changed, and it does not need to. What has changed is only what you now know about the particular patch of dark it occupies. A small, quiet, restless little star with a family of its own, sitting exactly as far away as it has always sat, neither closer nor farther for anything this walk has covered tonight. This crossing was never truly dark. For the whole of the first half at least, the light you travel by is the one behind you, not the one ahead, and there is nothing troubling in that. It is simply how a long walk works. You do not need to see the end of it to be moving steadily, calmly, safely through the middle of it. Most nights ask something similar of anyone lying quietly beneath them, waiting for sleep to arrive on its own schedule rather than on command. The morning is not visible from here either. There is only the plain trust that it is coming, the same way this walk trusted a destination it never once got to see. Whatever tomorrow holds is, tonight, exactly as unseen as Proxima was from the midpoint, and exactly as real for being unseen. That is not a small thing to borrow from an entire night spent walking between two stars. It is, in its own quiet way, the whole of what this journey was built to leave behind. Every star this walk touched tonight is still exactly where it was before you closed your eyes to picture any of it. The bright pair, the small red companion and its quiet worlds, the thin material drifting between them, the boundary the Sunday breathes in and out, none of it needs tending and none of it is waiting on you. It will all still be there, unhurried, doing exactly what it has always done, whether or not anyone is awake to walk through it again. None of it was ever waiting for you to arrive, either, and there is a kind of quiet permission in that. A walk with nothing, depending on whether it gets finished, is the easiest kind of walk to simply stop taking. Whenever the body is ready to stop, sleep can arrive at any point along this same route and lose nothing, because nothing out here was ever keeping score. If this slow walk helped carry you, or someone you love, a little closer to sleep tonight, this same journey will be waiting again on Spotify, ready whenever the next quiet night calls for it. The room can stay exactly as still as it already is. Nothing from tonight needs remembering by morning. Rest now. Good night.